Okay, Algebra 2, Semester 1 students. This is Mr. Bear, and I'm going to show you Unit 1.4. I know this is the second time in a row that you've had to do a video lesson, so I'm going to try to keep this pretty straightforward. Good news is some of this may be a review from Algebra 1, but I do fully intend to go over this and the 1.3 materials as a review on Friday, okay? So let's go ahead. So you'll start by doing your bell work questions and you'll turn that into the guest teacher after the skill check. Okay. So 1.4 is system of inequalities. So we're going to start with some basic how do we graph inequalities. So the first thing you want to do is put your inequalities in slope-intercept form. Okay, so that's that y equals mx plus b form. So if I look at my first inequality, this is already in slope-intercept form, so I'm good to go there. However, the second inequality is not in slope-intercept form, so I need to solve for y. So I'm going to subtract 2x on both sides, and that will fortunately get me y is greater than or equal to negative 2x plus 3. Now, yes, I am putting that 3 minus 2x, I'm putting it in the slope-intercept form where the x part comes first and then the b. Okay, so now that my inequalities are written, then what I'm going to do is I'm going to graph the lines. If your inequality just has a greater than or less than symbol, meaning nothing underneath it, you use a dotted line. And if there is a bar underneath to mean equal to, use a solid line. Okay, so I'm going to do that for each of these. So on the first one, I'm going to use a, let's see, it'd be a dotted line. So dotted line for that one. So I'm going to graph this y equals 4x minus 3, just like I normally would. Slope is 4, so I'm going to rise 4 and run 1. Maybe do that a handful more times. You can also go down 4 and left 1. But it's going to be a dotted line, so when I graph this, I graph it like so. On Delta Math, it will say like change line. So if you graph it and it's solid, click change line, it'll change it to dotted. Okay, for the shaded area, well, we'll get to that in a moment. Let me graph the other line. So this one has a greater than or equal to. So when I do that one, I'm going to do a solid line. My y-intercept is 3. My slope is negative 2. So I'm going to go down 2 and write 1. This time I'm not going to graph a bunch of them because I can already see where they overlap. So now what we need to do is we need to shade the appropriate area for each line. Okay. So the way I do this is, since these are in slope-intercept form, if I have a greater than or equal to, you shade above. If I have a less than or equal to, I shade below. Okay, since my first graph, the blue one that I drew here, it has a greater than, I would be shading everywhere above that. So what I'm going to do is I'm going to take the highlighter feature, if I can figure out, there we go. So I'd be looking at everything, whoops, sorry, I'm shading that in the wrong spot. I want to shade above that blue line. So that's going to be, now it's not going to let me do it. Let's try it again. Everything above the blue, but don't actually graph that on your paper yet, because I'm going to show you the other one, which I'll do in green. Actually, let's see, yellow and blue make green. I'll do light blue. For this one down here, well, maybe. This isn't cooperating. Anyway, the bottom one has a greater than, so we're going to shade above the red line as well. That's going to be all this here. And the part that just turned green is actually going to be your intersection. And that is what we want as our solution. So you know what? This is being a turd. So I'm just going to delete all of this. And I'm going to take my pen. I'm going to pick the green. And this is the part that is ultimately shaded. Okay? Everything between these red and blue lines, because that section is what's above the blue and above the green. Okay, so the way we would do that is it says your the solution region of your shading is the, I guess it's just your solution is your shaded region. Sorry, I did not make these notes and I could not remember what words they wanted there. But basically anything that's in that green is going to be a solution. Okay? You will only have to do like one, maybe two of these on Delta Math where you actually graph them. Okay? All right, this is more like what you'll need to know how to do for a test. So on a test, I will give you inequalities like this, and I'll give you two ordered pairs, and you have to figure out if they'll work or not. So on part A, I have an x value of -2 and a y value of 6. So what I'm going to do is I'm going to plug those numbers into this system here and see if it works. So let's start with the first one. Y is greater than 4. Well, in this case, that would be 6 is greater than 4. That is true. So now I go to the other inequality, and I replace the x with -2, and I'm going to replace the y with 6. That gives me -4 plus 6. -4 plus 6 is 2, and 2 is less than 10. So for letter A, yes, this is a solution. Okay, versus on part B, now our x is 3 and our y is 4. If I plug in for the first inequality, we have 4 is greater than 4. That is not true. In order for those to actually be true, you'd have to have greater than or equal to 4. Not true, which means that automatically no, 3, 4 is not a solution. Okay, so it's just a matter of plugging in your x and y to your equations or your inequalities and seeing if it works. Now, since the first one wasn't true when I did part B, since the first inequality, the y is greater than 4 is not true, you don't have to check the other one because if it's not true for one, it's not true for the system. Okay? All right, how about this one? This time I give you a graph and I want you to determine which points are on it. So points on a dotted line are never, write this down, solutions. I don't care if it's next to the shaded region. If you have a point that's on a dotted line, it will never be a solution. It can't be. All right, so on letter A, we have 2, -1. So if I go over to 2 and down to -1, that's this point here. And as you can see, it's on a dotted line. So not a solution on a dotted line. Now you might be saying, Mr. Bear, it's on a solid line too. Yes, you're right, but it is not a solution because it's also on a dotted line. How about 0, 1? 0, 1 is this point here. Well, that is okay. It is a solution because it's on a solid line next to the shaded region. Okay. Now, how about the, let's see, what color can I use? Let's use blue. No, let's not use blue. Let's use green. -2, -3. That's going to be this point down here. And that is not a solution. And again, it's on a dotted line. Okay. All right. So there's that. These ones are going to ask you to graph a system. I'm going to skip this example here, just completely cross it out. We're not going to deal with that. But let's look at this one here. So x minus y is less than or equal to 5. I'm going to take that inequality. I'm going to solve for y, because in order to do this, I have to get y by itself. So I get negative 1y is less than or equal to 1x plus 5. I'm just putting my 1's in front of my variables. Then I'm going to divide everything by negative 1. And when you divide an inequality by a negative, it flips the direction of the inequality. Okay, so when you divide by a negative, it flips the inequality. So just remember that. All right, so I'm going to graph that line down at negative 5. And I'm going to go down 1, right 1. Or I could go up 1, left 1. And I'm going to use a solid line. The reason I'm using a solid line is because of the greater than or equal to. Then I'm going to do the next one here. Let me go and do that out in the side with red. Okay, so we're going to add 2x to both sides. That'll give me 3y is greater than 2x minus 9. Then we're going to divide by 3. Now, unlike the last example, when I divided by negative 1, I had to flip the inequality. On this one, I divided by a positive 3, so I don't have to flip the inequality sign. This is my inequality, so I'm going to graph that. Negative 3 is my y-intercept. Let's see. Slope is 2/3, so I'm going to rise 2 and run 3. I'm going to use a dotted line here. And now I'm going to find my solution region, which I'll graph in green. So this one here means shade above. This one here means shade below. No, that does not say below. Okay, so I need to be above the blue line, but below the red line. So that's going to be this region here. That fits both criteria. Okay. Now it's asking us for a point that is a solution. So one point that is a solution here, if I look, maybe I do 0, negative 5. That's on a solid line right next to the shaded. Or maybe I also just pick something that's solidly in the shaded. So maybe like 4, negative 4. That's this point here. Definitely a solution. A point that is not a solution would be any point that is either on a dotted line or not in the shaded region. So like, for example, I might have 0, negative 3. Not a solution because that is on a dotted line. Or maybe another one would be negative 1, negative 4. That's going to be the intersection point, but it can't work because it's on a dotted line. And those are just 2 answers for these. There are many, many more, but just those are 2 answers to that. Okay. All right. I'm not going to do this one, but you could try it if you want. And now what you're going to do is you're going to complete your skill check on the back side of the bell work. Turn that into the guest teacher when you get done, and then you'll work on 1.4 IP on Delta Math. And yes, tomorrow in class I will review this lesson and the 1.3, which hopefully you're doing okay with.